Hello guys. There are a couple of boards on this video that I want to check PWM of their CPU blocks and also MOSFETs. I showed you how to test MOSFETs out of boards on other videos. Now I want to show you how to test them on boards. As you know, there is a possibility that this test might not work. So whenever you doubt it, you need to remove MOSFETs and check them outside boards. There are some high MOSFETs on PWMs which you can see here. High MOSFET is a MOSFET that its drain pin connects to 12 volt. And its source pin is phase that connects to these inductors. And drain pins of low MOSFETs connect to phase. And their source pins connect to GND. Let me show you that. I'll set the multimeter on buzzer mode to show you the connections. As I said, drain pin of high MOSFET connects to 12 volt. And its source pin connects to phases that I need to show on the back. I should say that this source pin connects to drain of low MOSFET too. And in order to test easier, I can place the probe on drain of low MOSFET and on the back. These three dots are inductors. And they are phases. And as you see, each one of these is connected to all three of them, meaning these inductors are connected to each other as parallel. And source of low MOSFET is connected to GND. In fact, all of them are connected to GND. So 12 volt enters the high MOSFET. And 1.2 volt is present on phase, depending on the voltage that CPU consumes. And the source pin is the GND. Now let's test these MOSFETs.
Hello everyone, today I'm excited to introduce you to Finti, game-changing accounting software designed for businesses like yours. Whether you're running a repair shop, a retail store, or any service-oriented business, Finti is here to revolutionize how you manage your finances and operations. Join me as we explore the key features that make Finti the go-to solution for small to medium-sized businesses. Efficient repair shop management. Let's begin with repair shop management. Finti allows you to seamlessly handle device repairs. Imagine printing receipts with just a click or sending eco-friendly text messages to your clients automatically. No more hassle, just efficient and organized repair shop management. Invoices and financial transactions. Creating invoices and tracking financial transactions have never been easier. Whether you're issuing receipts or managing expenses, Finti simplifies the process. Plus, if your team works on commissions, Finti's got you covered. Set commission percentages effortlessly and let the software handle the calculations, providing you with detailed reports. User-friendly tutorials. Now let's talk about how to use Finti. Finti is designed with you in mind. Accessing tutorial videos is just a click away. Whenever you have a question or need guidance, simply click on the red icons within the software to watch related tutorial videos. And if you need assistance, feel free to reach out to our support team. They are ready and eager to help you whenever you need. Online accessibility and global currency support. With Finti, flexibility is key. Access your account and manage your business from anywhere, anytime using your smartphone or laptop. And guess what? Finti supports over 20 major world currencies, ensuring users from around the globe can easily navigate and utilize the platform. Don't see your currency? No problem. Our support team is here to assist you, customized to suit your business. Whether you're in the repair industry or looking for top-notch accounting and inventory management. We can even disable features you don't need, providing a personalized experience just for you. In conclusion, Finti is not just accounting software. It's a business companion designed to simplify your operations and boost your efficiency. Join the global community benefiting from Finty's powerful features. Subscribe now, use the exclusive 50% discount coupon, and let Finty elevate your business to new heights. Thank you for watching and happy managing.
As you know, there is a diode inside MOSFETs from source to drain. That is diotic, and gate is insulated from source and drain. And when MOSFET is on board, these pins make some connections with each other through their PWM IC, and the insulation state gets eliminated. Let's go to board and see how to test high and low MOSFETs. I set the multimeter on diode mode. And I'll check source to drain first. As you see, 0.488 volt appears on this way, and 400 millivolts to 800 millivolts is normal for diodes. Usually up to 500 millivolts appears on diodes, and nothing should appear on the other way, but as it's on the circuit, a high value appears because of other components. 2.6 volt is battery voltage, which is so high. But if low value appeared on this way too, I can say that the MOSFET is connected on both ways and it's burned. So, as high value appears on this way, in fact, I can say that it doesn't let anything pass through. As you see, 2.6 volt is so high. So this is it. It's so easy to test a high MOSFET. 400 to 800 should appear on this way, and on the other way, it shouldn't show any value, or if it did, it should be so high, which is 2600 millivolt here, which is so high. So this was high MOSFETs. Now, in order not to test these MOSFETs one by one, because as I said, all of them are connected to each other, so I need to place a probe on source pin of high MOSFET or drain pin of low MOSFET, because they are connected to each other on all these MOSFETs. All of these are connected to each other, and this is connected to that because it's phase. And these pins are connected to each other. So this pin is connected to this, which means all of these are connected to each other. So I can place a probe on this pin, or a pin of these inductors. I'll place it on drain pin of low MOSFET as it's much easier. And drain of low MOSFET is connected to source of high MOSFET. So I place the black probe on drain of low MOSFET, and place red probe on 12 volt pin of ATX jack. Depending on the pin direction, these two pins on the left on ATX jack are 12 volt, and two pins on the right that are connected to each other are GND. As you see, they show 0 with GND. So right pins are GND, and the left pins are 12 volt. So I'll place a probe on source of high MOSFET, meaning I place it on phase, and the other probe on 12 volt. So this is the test I'm performing now. I check 12 volt with source and high value appears, like this. It's not connected on this way, meaning it shows high value, and by reversing the probes, it should show 400 to 800, which is 486 now. So I can say that all high MOSFETs are checked with one test and they're normal. It doesn't matter if I place probe on these MOSFETs or drain of this MOSFET, because they're connected to each other. So high MOSFETs were easily tested. Only their internal diodes. All check their gates now. I tested source to drain, and their gate shouldn't show low value with either of these MOSFETs. So for example, if gate to source shows low value, it means that they are connected to each other. As you see, gate to drain shows a high value. And I'm checking gate to source, it is 1800 millivolt, which is so high. Which means that gate of this MOSFET is insulated from source and drain. And this is the connection between pins through PWM. So you need to check gates with source and drain, which should show high values. You can do it on both ways and the values might differ. As you see, it's different on this way. All of them show high values. So you saw how the connections are. And I easily checked MOSFETs on the board. All high MOSFETs are tested, now I need to check low MOSFETs. You need to know a special trick to test low MOSFETs. Meaning, if CPU is on the board, the value that a low MOSFET shows is actually CPU resistance which is present on these inductors. This is why you need to remove CPU from boards to be able to only test low MOSFET. I removed the CPU of this board. Now drain to source should be around 500. As you see, it shouldn't be connected on this way, which is right. Because it's an N-channel MOSFET and high value should appear. And on the other way, it needs to be between 400 and 800. It gets 0 for a second, it's because there is a capacitor on the circuit. The capacitor gets charged. The capacitor lets DC voltage pass through in the first second. Then it starts getting charged. And then it shows diode value which is 483. Next one. It is 483. And these three should show the same value because they're connected to each other. I'm checking phase with GND. So to test all of it, I'll place a probe on drain of low MOSFET and the other one on GND. It's 0 for a second, it's because of capacitor charge. It shows high value on this way, and on the other way. It's between 400 millivolts to 800 millivolts. So this means that all low MOSFETs are working. Or you can check GND through this jack. It doesn't matter. It's between 400 and 800 on one way. It's in reverse bias. And on this way, it should be between 400 and 800. So this is how to test low MOSFETs. The only thing that's left is gate pin. This pin is gate, and as source pin is connected to GND, I can check it here. As you see, it shows high value with source pin. It shows high value with drain too. You need to check the gate pins one by one. Because gate of each of these is different inside IC. It goes to different pins of IC. So this is it. So this board is brought to me and I want to test it. So as I explained, I set the multimeter on diode mode. Let's see how to test it. It's on diode mode. I'll check drain of low MOSFET with 12 volt. It's 486 on this way. I'll reverse the probes. High value appears. So internal diodes of all high MOSFETs are okay. Time to check gate pins now. So I need to check each of the gates with source and drain. If they show high value on one way, it means that they're okay. I can check them on this way. So I checked all high MOSFETs in a couple of seconds. Testing low MOSFETs is the same. I check drain pin of low MOSFET with GND. High value on this way. And on the other way. After charging the capacitor, it's between 400 and 800. So all low MOSFETs are working as well. Their gate shows high value as well. This is it. So this was how to test PWM MOSFETs. But I didn't test MOSFETs of this block and only worked on here. You can generalize this to those blocks as well. I should say only gates are left to check. Check them and easily test MOSFETs. There is another situation too, and that is when CPU is on circuit. If CPU is placed on a circuit, you can't easily be sure of low MOSFET, because low MOSFET gets parallelized with CPU. And that way, you check CPU resistance. All perform the same test on the other board now. We'll see that we won't get the proper value. And this is not the problem. The problem is that the CPU is on the circuit. I'll check high MOSFET first. As I said, to test high MOSFET, I need to check drain of low MOSFET with 12 volt. Two upper pins are most probably 12 volt. I need to detect pins first. Two upper pins are connected to each other and are not connected to GND. So these two upper pins are 12 volt. By checking it with 12 volt, it shows high value on this way. And on the other way, it's between 400 and 800. So this means all high MOSFETs are normal. And I'll check their gate pins now. As I said, I'll check them with source once. High value appears. Sorry, I was checking drain. Now I check them with source. This is high value too. This one. Also high value. And this is it. High MOSFETs are normal. But I didn't check this one. You can check and see it on your device if you wish. Now I check low MOSFETs. For example, I'll check a low MOSFET with GND. As you see, 7 appears. Which means that this block of the board is suspicious. So either the MOSFET is problematic, or this happens because CPU is on the circuit. Let me remove the CPU and you'll see it's because of that. And the board is okay. And the MOSFETs are okay too. Take a look. It's okay now. I'll reverse the probes now. It gets charged and shows high value. So this is it. So when CPU is on the board, we can't make sure of low MOSFETs. And the low value that appears doesn't mean they're shorted. And you don't need to remove them unless the CPU is not removable. That way, and if MOSFETs are suspicious, you need to remove them. Low ohm appears here. I'll check gate 2. As you see, gate pin has high resistance. Now I check gate with source. This somehow means that gate is not shorted to source and drain. And I can almost say that the MOSFET is okay. But I can make sure when source to drain would have high resistance too. For that, CPU needs to be removed. I hope you can easily analyze PWM now. It's so easy to test high and low MOSFETs. Take it easy. As I showed you, you can check them on boards first. Remove CPU and check them. And if they were suspicious, you can remove the MOSFETs and test them outside boards, exactly as I showed you guys. PC boards usually consist of PWMs. And there is another one here. But sometimes low MOSFET of this one shows low resistance. For that I need to remove MOSFET, and by checking ohm of this inductor, it usually shows around 30 to 40 ohm. And by checking it on diode mode, it might not show 400 to 800. Which would make you be suspicious of this block. All show that too. Let me know how it is on this board and another one. Let's check PWM of this board now. I'll check these MOSFETs. Let me set multimeter on diode mode. Source to drain. Yes, it's 200 to 300 on this way. I'll reverse the probes. Maybe it's a Schottky diode. Take a look. I can't be completely sure of source to drain by reversing the probes. While it might be okay, because it was 200 to 300 on this way, and on the other way, it was 400 to 500. Let me check it with gate. As you see, it is a high value, meaning it is insulated. Take a look. Gate is insulated from source and drain. This MOSFET is most probably okay, considering its reaction. As you see, the value that appears as normal on this way, and on the other way, it's a bit different. If a diode faces a problem, it usually shows similar values on both ways. Or it doesn't show anything if it's disconnected. I'll check high MOSFET now. It's 400 to 800 on this way. And on the other way, it's a high value. High MOSFETs can be checked so easily. But for low MOSFET, as it gets parallelized with PWM of internal components, so it seems like CPU is placed on the board while checking low MOSFETs. So I can't make sure of this either. But by considering its reaction, I was somehow able to say it is okay or not. But if it was still suspicious, just remove and test it. I'll bring another newer board. Take a look. I'll check high MOSFET. High value appears on this way, and on the other way, it's between 400 and 800. So this means that its internal diode is most probably normal. And source to gate. 3 left pins are source, 4th one is gate. High value appears, also high value for gate to drain. High MOSFET is most probably normal. I'll check source to drain of low MOSFET and a low value appears. I'll reverse it now. The same value might appear. What I'm doing now is checking phase of this inductor with GND. It is 44. Phase of inductor is on these pins and source is on GND. In fact, I'm checking resistance of this inductor with GND. And 32 ohm is normal for this part. And if I was suspicious to this, I needed to remove it. But I should say that it's normal. I'll check its gate too. 29 appears for gate and source. Let me check gate to drain. It's 60. To check this part according to my explanation for CPU PWM, it seems problematic. In fact, this block is like when CPU was on circuit and I couldn't be completely sure. And I need to be careful with low MOSFET. So this was PWM of this block. We made sure of the CPU. And there aren't many other components left other than PWMs on the circuit. Or if regulator was on the board for which I need to check its datasheet. If there was a regulator, I need to check that on the board. Checking power and PWMs is easy. And there are some components and 2 regulators, which I talked about on previous videos. And if power block was fine and you checked clock too, and if clocks were okay, signal directions would be left to check. That way, chip might be problematic, or I/O signal direction might be problematic. I/O is removed from this board. Usually in 90% of the cases, if all power voltages are okay. Chipset gets problematic, which I have repaired a lot of boards by resoldering this chipset. Or sometimes audio card faces problems. Or LAN IC faces problems, which you can remove them and check board without them. If circuit worked fine without them, you can place back the components you removed. PC boards doesn't have any other specific components to be tricky. Wish you success in your work. And enjoy. Thanks for watching.